Hi everyone, in this video tutorial we are going to be going over how to name more complex alkyl substituents. These are substituents that are not just simple straight chains, or they're not your common name substituents like your isopropyl, isobutyl, secbutyl, tertbutyl, and neopentyl group. Now the IUPAC nomenclature system has kind of shifted to starting to use the Alkanyl style of naming these more complex substituents, where we have our alkyl prefix. We say AN, and then there's usually a locant, and then the suffix YL, the Alkanyl style of nomenclature. There is a slightly different style of nomenclature that is still used and is accepted, but we're going to focus on this because I think this is the best way to do it, as well as it's the way that a lot of teachers are starting to shift. Okay, so how does the system work? In this style of naming more complex branch substituents, you will number the substituent in the direction that gives the position of free valence. This is really important. The position of free valence, the lowest locant. So what that means is if you looked at this more complex branch substituent, the numbering would not be 1, 2, 3. The correct numbering is down here. We number in the direction that gives that position of free valence where we're connecting to the parent hydrocarbon, the lower locant preferentially. And what you'll notice here is this kind of the complex name, right? Our Alkanyl style of naming. That substituent will be placed in parentheses, and the locant denoting that position of free valence, the attachment point to the parent hydrocarbon, is placed at the end of that Alkanyl name, that substituent name, before the il. That is the position of free valence, where our complex substituent is connecting to the parent hydrocarbon, and we number that complex substituent to give that lowest locant to the position of free valence. Okay, and then of course we have a chain, right? And it's complex, it's branch. So we're actually having to denote then any substituents off of our substituent, which is kind of a funky way of thinking about it, but that's a good way of thinking about it. So let's visually process this a little bit and dissect how we use this Alkanyl style of naming. So we look at a substituent and we acknowledge that it's not just some straight chain, and it's also not one of our common names. We will number that chain to give the position of free valence the lowest locant possible. And then you're going to acknowledge, okay, that's kind of our longest continuous chain of our substituent. And at the 3 position, there is a methyl group. That's our processing of it so far. And if you were to build this overall name for the compound, we would have 1, 2, 3, or 1, 2, 3 as our numbering. But the correct numbering is 1, 2, 3 for our substituents, giving the first name substituent that lower locant, as we've talked about. Okay, so that's the numbering of our parent hydrocarbon, which is the 6-membered ring. So we have 1-bromo-3, and at the 3rd position, we have our complex substituent. Now, we said that we would put our complex substituent in parentheses. So notice we have parentheses kind of capturing this entire complex substituent. So this locant represents where on the parent hydrocarbon our complex substituent is. Then what we would do is essentially almost name this as a compound itself. It's kind of in essence what we're doing. We're saying that on our 4-carbon chain, at the 3 position, there's a methyl. So we're saying we have 3-methyl, and the substituent length is 4 carbons. So we say butan. So we use our Alkanyl. Notice we have AN instead of but, which is normally how we would name a substituent, just butyl. We say butan, and then we say, one second here real quick, we say -2-il, and that is our complex substituent, where that locant coming before the suffix YL is indicating which locant on our complex substituent is connecting to the parent hydrocarbon. All right, I know this can be a little confusing, so let's break that down again. We acknowledge here that there's a complex substituent. We number the chain of that substituent to give the lowest locant to that position of free valence. We then almost name it as its own compound. So we say 3-methyl, there's a methyl at the third position on that chain. Butan, signifying that that chain, our substituent, the longest continuous chain of the substituent, is 4 carbons, and it's the 2 position of that substituent that is connecting to the parent hydrocarbon. The position of free valence on our substituent is the 2 position, and that is the entire substituent, and it was located at the locant 3 on our parent hydrocarbon. Okay, so we're going to go over a couple more examples here to really hone this style of nomenclature, because it certainly is confusing at first. And again, this annotation here, this dashed line, is essentially showing where we would connect to the parent hydrocarbon. Take a second to visually process this above. I circled here our substituent, our complex substituent, and that dashed position is essentially where we're connecting to that parent hydrocarbon. So that's what we're going to be looking at with these examples. So here's a complex branch substituent. We are going to number in the direction that would give the position of free valence, this guy right here, the lowest locant, which we have done. And we're going to say at the third position, there's a methyl group, 3-methyl. It's 4 carbons long, butan-1-il, signifying that it's the 1 carbon, our position of free valence, that is connecting to the parent hydrocarbon. And of course, this locant before would signify what locant it was on the parent hydrocarbon that we had this complex substituent attaching. Here's another example below. We now have a 5 carbon chain, and at the 4 position there's a methyl. So our complex substituent gets put in parentheses. We have 4-methyl, denoting our substituents on our substituent chain. 4-methyl pentan, and then we give our locant 1-il, where the 1 is saying that the position of free valence is the 1 carbon on our substituent chain. Let's now look at a couple examples again here. We have our complex substituent. It is going to be 4 carbons long. We do not number 1, 2, 3, 4 because the blue numbering would give the position of free valence the 3 locant, but we want to give it the 2 locant. So the red numbering that I provided ahead of time here is the correct numbering. So we're going to say this is a complex substituent, and at the 4 position there's a bromine. So we have 4-bromo, butan, signifying 4 carbons, -2-il. And it is that second carbon that is the position of free valence that is connecting to the parent hydrocarbon. The example below, we have a 5 carbon chain. Okay, now because this is going to be numbered in either direction to give the position of free valence the 3, it technically doesn't matter which way we number this. However, let's look at the example to the far right, which is just a little bit different, right? We have a methyl group now. Now there is a correct directionality, because either way we number this, in this direction or in this direction, we are going to give the position of free valence the locant 3, okay? But the correct numbering is the numbering provided ahead of time, because it also then gives our substituent off of our complex substituent the lower locant, which is the 2, as opposed to numbering in this direction. In blue will be the incorrect numbering. That would give the methyl the 4 locant, but we want the lower locant preferentially if possible. Okay, so the blue numbering was incorrect. The red numbering provided ahead of time is correct. We would say then complex substituent at the 2 position, there is a methyl group. And overall, that substituent or complex substituent is 5 carbons. So we say pentan, and it is at the 3 position on our complex substituent that we have the position of free valence that is connecting to the parent hydrocarbon. Okay, so one last example, and then we're going to summarize this real quick, because I know this is a goofy topic. Here we have another complex substituent with multiple branches off of the longest chain of the complex substituent. So there's the longest continuous chain of our complex substituent. We number in this direction. to give the overall lowest locant set to those substituents off of our complex substituent. And we would say that there are 3 methyl groups, 1 at the 3rd position and 2 at the 5 position. So therefore, we put our complex substituent in parentheses. We have 3, 5, 5 dash trimethyl hexan dash 2-il, hexan dash 2 dash il. Okay, so it's possible that you'll have a number of substituents or branches off of our complex substituents longest chain. And we will specify that before we specify our complex substituents longest chain. And again, this number here signifies the position of free valence on our complex substituents longest chain. All right, so this is the Alkanyl style of naming complex substituents. And again, we essentially will number our substituent in the direction that gives the position of free valence the lowest locant. We place our entire complex substituent in parentheses, naming any branches off of it, any substituents of our complex substituent, before that longest chain alkyl prefix, and before the y-il component, we put the locant, which signifies the position of free valence, which, going back to our original example here, that position of free valence was at the 2 position, and therefore it was the locant 2 that came before the il. And a locant that precedes the parentheses of your complex substituent is saying where on the parent hydrocarbon is that complex substituent attached. Okay, so these locants might be the same, or they could be different, because the 3rd position is on the parent hydrocarbon, but the 2nd position is on the complex substituent. So I can't stress this enough. This will take a little bit of time, and if you need to, watch this video over again and really be meticulous as you watch it. Process it visually, get your definition straight for the position of free valence, and pay attention to locants.